The latest editions of IEEE C57.12.01 and C57.12.20 introduce several significant changes for TP-1 K4 and K13 transformers. These updates impact various aspects of transformer design, testing, and installation, all aimed at enhancing safety, reliability, and performance. It's crucial for manufacturers, engineers, and end users to be well versed in these changes to ensure compliance. Firstly, short-circuit current ratings have been updated. Transformers must now be rated for a minimum short-circuit current of 40 kA for 3 seconds. Transformers with ratings below 40 kA must undergo testing to demonstrate their short-circuit withstand capability. This ensures that transformers can handle fault currents without catastrophic failure. Secondly, there are new minimum temperature rise limits. The maximum temperature rise for TP-1 K4 transformers is being reduced from 150 degrees Celsius to 135 degrees Celsius. The maximum temperature rise for TP-1 K13 transformers remains at 125 degrees Celsius. These limits help prevent overheating and extend the lifespan of the transformer. Thirdly, load tap changers, or LTCs, now have updated requirements. LTC are now required to be rated for a minimum of 150% of the transformer's rated current. Furthermore, LTC must be able to withstand a minimum of 100,000 load transfer operations. This ensures that LTC can reliably adjust voltage levels under varying load conditions. Fourthly, insulation strength has been increased for both K4 and K13 transformers. The basic impulse insulation level, or BIL, and impulse withstand level, or IEEE, requirements have been updated. Higher insulation strength protects the transformer from voltage surges and transients. Fifthly, dielectric tests have become more stringent. The impulse test voltage and duration have been increased. The partial discharge, or PD, test requirements are now more stringent. These enhancements ensure that the transformer's insulation system is robust and free from defects. Sixthly, thermal tests have been modified. The temperature rise tests now include both steady state and transient conditions. The overload capacity requirements have been updated. These changes provide a more comprehensive assessment of the transformer's thermal performance under different operating scenarios. Seventhly, mechanical tests have been updated. The mechanical strength requirements have been updated, including seismic and vibration tests. These tests ensure that the transformer can withstand mechanical stresses and environmental factors. Eighthly, environmental tests are now a key part of compliance. Transformers must be able to withstand various environmental conditions, such as humidity, temperature, and altitude. This ensures reliable operation in diverse environments. Ninthly, documentation requirements have been expanded. Detailed documentation is now required, including test reports, design calculations, and maintenance instructions. This provides a comprehensive record of the transformer's performance and facilitates maintenance. Tenthly, conformity assessment is essential. Transformers must be certified by a recognized testing laboratory to meet the new requirements. This ensures that the transformer has been independently verified to comply with the latest standards. In more detail regarding short-circuit current ratings, the 40 kA for 3 seconds rating is a minimum requirement. Depending on the specific application and grid conditions, a higher short-circuit current rating may be necessary. Engineers should carefully analyze the fault currents at the installation location to determine the appropriate short-circuit current rating for the transformer. When testing transformers with ratings below 40 kA, it is essential to follow the testing procedures outlined in the relevant IEEE standards. The testing should simulate the expected fault conditions to verify the transformer's ability to withstand the short-circuit current. Regarding temperature rise limits, the reduction in the maximum temperature rise for TP-1 K4 transformers reflects advancements in insulation materials and cooling techniques. Lower operating temperatures extend the life of the transformer by reducing the rate of insulation degradation. The temperature rise limits are based on the average winding temperature, which is determined by measuring the resistance of the windings before and after the temperature rise test. The ambient temperature must also be carefully controlled during the test to ensure accurate results. For load tap changes, the 150% current rating ensures that the LTC can handle overload conditions without overheating or failing. The 100,000 load transfer operation requirement reflects the expected duty cycle of the LTC over its lifespan. LTC should be regularly inspected and maintained to ensure proper operation and prevent premature failure. Insulation strength improvements include updates to both the BIL and IWL requirements. The BIL is the maximum impulse voltage that the transformer can withstand without insulation failure. The IWL is the impulse voltage that the transformer can withstand without damage. Higher BIL and IWL values provide greater protection against lightning strikes and switching surges. Dielectric testing now includes increased impulse test voltage and duration. The impulse test simulates the effects of lightning strikes and switching surges in the transformer's insulation system. Partial discharge testing is used to detect defects in the insulation system that can lead to premature failure. The more stringent PD test requirements ensure that transformers are free from insulation defects before being placed in service. The modifications to thermal tests involve both steady state and transient conditions. Steady state temperature rise tests are conducted under continuous load conditions. Transient temperature rise tests are conducted under varying load conditions to simulate real-world operating scenarios. Overload capacity requirements are updated to reflect the increasing demands on transformers in modern power systems. Updated mechanical tests include seismic and vibration testing. Seismic testing verifies the transformer's ability to withstand earthquakes. Vibration testing verifies the transformer's ability to withstand vibrations from nearby equipment or transportation. These tests are particularly important for transformers installed in seismically active areas or near sources of vibration. Environmental testing includes humidity, temperature, and altitude tests. Humidity tests verify the transformer's ability to withstand high humidity conditions. Temperature tests verify the transformer's ability to operate over a wide range of temperatures. Altitude tests verify the transformer's ability to operate at high altitudes where the air is thinner. Detailed documentation includes test reports, design calculations, and maintenance instructions. Test reports provide a record of the transformer's performance during testing. Design calculations provide a basis for the transformer's design and performance. Maintenance instructions provide guidance on how to properly maintain the transformer over its lifespan. Conformity assessment requires certification by a recognized testing laboratory. The testing laboratory must be accredited to perform the required tests. The certification process ensures that the transformer meets the requirements of the relevant standards. These new requirements are designed to improve the safety, reliability, and performance of TP-1 K4 and K13 transformers. By adhering to these standards, manufacturers, engineers, and end users can ensure that transformers operate safely and efficiently for many years. The impact of these new requirements is significant. Transformer manufacturers may need to redesign their products to meet the new standards. Testing laboratories will need to update their testing procedures to comply with the new requirements. Engineers will need to be aware of the new requirements when designing and installing transformer systems. End users will need to ensure that their transformers are certified to meet the new standards. Compliance with these new requirements will ultimately lead to safer, more reliable, and more efficient power systems. It is essential for all stakeholders in the transformer industry to work together to ensure that these new requirements are properly implemented and enforced. In addition to the specific changes outlined above, there are also some general considerations to keep in mind when working with TP-1 K4 and K13 transformers. Firstly, proper installation is crucial for ensuring the safe and reliable operation of the transformer. The installation should be performed by qualified personnel in accordance with the manufacturer's instructions and all applicable codes and standards. Secondly, regular maintenance is essential for extending the life of the transformer. Maintenance should include periodic inspections, cleaning, and testing. Any problems that are identified during maintenance should be promptly addressed. Thirdly, proper protection is necessary to protect the transformer from damage due to overloads, short circuits, and other faults. Protection devices such as fuses, circuit breakers, and relays should be properly sized and coordinated to provide adequate protection. Fourthly, proper grounding is essential for ensuring the safety of personnel and equipment. The transformer should be properly grounded in accordance with all applicable codes and standards. Fifthly, proper ventilation is necessary to prevent overheating of the transformer. The transformer should be installed in a well-ventilated area to allow for adequate cooling. Sixthly, proper handling is important to prevent damage to the transformer during transportation and installation. The transformer should be handled with care and protected from impact and vibration. Seventhly, proper storage is necessary to protect the transformer from damage during periods of inactivity. The transformer should be stored in a clean, dry, and well-ventilated area. Eighthly, proper disposal is required when the transformer reaches the end of its life. The transformer should be disposed of in accordance with all applicable environmental regulations. These general considerations, combined with the specific changes outlined above, provide a comprehensive framework for ensuring the safe, reliable, and efficient operation of TP-1 K4 and K13 transformers. By following these guidelines, stakeholders in the transformer industry can help to ensure that transformers continue to play a vital role in modern power systems. Furthermore, it is beneficial to understand the rationale behind each of these changes. For example, the increase in short-circuit current ratings is driven by the need to accommodate the increasing levels of fault current in modern power systems. The reduction in temperature rise limits is intended to improve the reliability and extend the lifespan of transformers. The updated requirements for load tap changes are designed to ensure that these devices can reliably adjust voltage levels under varying load conditions. The increase in insulation strength is aimed at protecting transformers from voltage surges and transients. The more stringent dielectric test requirements are intended to detect and eliminate insulation defects that can lead to premature failure. The modifications to thermal tests are designed to provide a more accurate assessment of the transformer's thermal performance. The updated mechanical tests are intended to ensure that transformers can withstand mechanical stresses and environmental factors. The environmental testing requirements are designed to ensure that transformers can operate reliably in diverse environments. The expanded documentation requirements are intended to provide a comprehensive record of the transformer's performance and facilitate maintenance. The conformity assessment requirements are designed to ensure that transformers meet the requirements of the relevant standards. By understanding the rationale behind these changes, stakeholders in the transformer industry can better appreciate their importance and implement them effectively. Moreover, it is essential to stay informed about any future updates or revisions to these standards. The IEEE C57 series of standards is regularly updated to reflect advancements in technology and changes in industry practices. By staying up to date on the latest revisions, stakeholders can ensure that they are always in compliance with the most current requirements. Additionally, it is beneficial to participate in industry forums and conferences where these standards are discussed and debated. This provides an opportunity to learn from other experts in the field and to contribute to the development of future standards. In conclusion, the new requirements for TP-1 K4 and K13 transformers represent a significant step forward in the effort to improve the safety, reliability, and performance of these critical components of modern power systems. By understanding these requirements, implementing them effectively, and staying informed about future updates, stakeholders in the transformer industry can help to ensure that transformers continue to operate safely and efficiently for many years to come. The changes to the TP-1 K4 and K13 transformer standards reflect an ongoing commitment to safety, reliability, and performance in electrical power systems. These revisions are not merely arbitrary adjustments, they are the result of extensive research, analysis, and collaboration among industry experts. Each modification is carefully considered to address specific challenges and to leverage advancements in technology and materials. The increase in short-circuit current ratings, for example, acknowledges the growing complexity and interconnectedness of modern grids. As power systems become more sophisticated, they are also more susceptible to faults that can generate high levels of current. Transformers must be able to withstand these currents without failing, as a failure can lead to widespread outages and significant economic losses. The reduction in temperature rise limits is another critical improvement. Heat is a major enemy of electrical equipment, as it accelerates the degradation of insulation and other components. By limiting the maximum temperature rise, the new standards help to extend the lifespan of transformers and reduce the risk of premature failure. The updated requirements for load tap changes are also noteworthy. LTC are essential for maintaining stable voltage levels in power systems, but they are also subject to wear and tear due to their frequent operation. The new standards ensure that LTC are robust enough to withstand the demands of modern grids and that they are properly maintained to prevent failures. The enhancements to insulation strength and dielectric testing are also crucial for ensuring the safety and reliability of transformers. Insulation failures can lead to catastrophic events such as explosions and fires. The new standards help to prevent these events by requiring stronger insulation and more rigorous testing. The modifications to thermal and mechanical test are designed to ensure that transformers can withstand the stresses of their operating environment. Transformers are often subjected to extreme temperatures, vibrations, and seismic forces. The new standards ensure that they are robust enough to withstand these conditions without failing. The environmental testing requirements are also important for ensuring that transformers can operate reliably in diverse climates. Transformers are often installed in harsh environments such as deserts, mountains, and coastal areas. The new standards ensure that they are able to withstand the challenges of these environments. The expanded documentation requirements are designed to improve the transparency and accountability of the transformer industry. By requiring detailed test reports, design calculations, and maintenance instructions, the new standards make it easier to track the performance of transformers and to identify potential problems. The conformity assessment requirements are also essential for ensuring that transformers meet the requirements of the new standards. By requiring certification by a recognized testing laboratory, the new standards provide assurance that transformers have been independently verified to comply with the latest requirements. In summary, the new requirements for TP-1 K4 and K13 transformers are a comprehensive set of improvements that are designed to enhance the safety, reliability, and performance of these critical components of modern power systems. By understanding these requirements and implementing them effectively, stakeholders in the transformer industry can help to ensure that transformers continue to operate safely and efficiently for many years to come. It is also important to note that the implementation of these new standards may require significant investments in new equipment, training, and procedures. However, these investments are justified by the long-term benefits of safer, more reliable, and more efficient power systems. The cost of a transformer failure can be substantial, including not only the cost of replacing the transformer but also the cost of lost production, damaged equipment, and potential injuries. By investing in compliance with the new standards, stakeholders can reduce the risk of these costly failures and ensure the long-term viability of their operations. Furthermore, compliance with the new standards can also provide a competitive advantage. Customers are increasingly demanding safer, more reliable, and more efficient products. By demonstrating compliance with the new standards, transformer manufacturers can differentiate themselves from their competitors and attract customers who are willing to pay a premium for quality and reliability. In addition to the specific requirements outlined in the new standards, there are also some best practices that stakeholders should consider when working with TP-1 K4 and K13 transformers. These best practices include proper installation, regular maintenance, proper protection, proper grounding, proper ventilation, proper handling, proper storage, and proper disposal. By following these best practices, stakeholders can further enhance the safety, reliability, and performance of their transformers. Proper installation is essential for ensuring that transformers operate safely and efficiently. Transformers should be installed by qualified personnel in accordance with the manufacturer's instructions and all applicable codes and standards. Regular maintenance is also crucial for extending the lifespan of transformers. Transformers should be inspected regularly for signs of wear and tear, and any problems should be addressed promptly. Proper protection is necessary to protect transformers from damage due to overloads, short circuits, and other faults. Protection devices such as fuses, circuit breakers, and relays should be properly sized and coordinated to provide adequate protection. Proper grounding is essential for ensuring the safety of personnel and equipment. Transformers should be properly grounded in accordance with all applicable codes and standards. Proper ventilation is necessary to prevent transformers from overheating. Transformers should be installed in a well-ventilated area to allow for adequate cooling. Proper handling is important to prevent damage to transformers during transportation and installation. Transformers should be handled with care and protected from impact and vibration. Proper storage is necessary to protect transformers from damage during periods of inactivity. Transformers should be stored in a clean, dry, and well-ventilated area. Proper disposal is required when transformers reach the end of their useful life. Transformers should be disposed of in accordance with all applicable environmental regulations. By following these best practices, stakeholders can further enhance the safety, reliability, and performance of their TP-1 K4 and K13 transformers. And that, in essence, sums up what is known about the evolving requirements related to TP-1 K4 and K13 transformers.